My name is John Kraft. I'm joined here by Mark Thorne. We both work for Analog Devices, and we've heard some great talks, especially in the last couple hours on phased array stuff. Luigi and Bailey gave very inspiring talks, and you may have heard those talks and said, how can I get started in phased array beamforming? And how can I learn something? Or I've got an idea that I want to prototype something with, but how do I get started with it? How can I do something physically with real hardware? And so that's what we want to talk to you about today, this new kit that Analog Devices has released called the PHASER. And we're going to talk about how to use that with GNU Radio. So we'll do a little bit about like what is beamforming. Luigi did that, Bailey did that, and we also have to do it. It's obligatory. Anytime you talk about phased arrays, you always have to say what it is. And then we'll talk a little bit about this phaser kit that we have, and it's actually demoed at our booth as well. And then we're going to talk about how to control it with Python, because then next we're going to talk about how to control it with the GNU Radio, but we're just going to use the Python block in GNU Radio, and I'll explain why I chose to do it that way and kind of the advantages of using GNU Radio with that Python embedded module block. And then hopefully we're going to do a live demo. You know, you never know if a live demo is going to work or not, but we'll give it a try. So obligatory stuff, right? Feels redundant, but we got to do it. Normal antenna, right? You point the antenna where it's pointed. That's where you get the greatest gain. Phased array antennas, we're also pointing the antennas, but we're steering it electronically. Generally, it's a flat array, although not in Bailey's case. And so you can't tell what direction the antenna is pointed just by looking at it. It's all done by electronically steering it. And here's a nifty little animation on how that comes together. So you have some RF source. It's shining down its RF goodness onto your array, and depending on the angle that source is, right, it's going to hit one element in the array before the other elements, and some very small amount of time later, like picoseconds later, tens of picoseconds later, it strikes the next element, and so on until it's shined across. This planar wave is shined across the entire array. And our goal is we want to pick some kind of a delay such that we can align all of these waves, all these signals for a given steering angle, and then we can sum them together coherently to improve our signal to noise ratio. That's how we steer the beam, by choosing that delay. And so that's been around for a long time. People have been doing that for a long time, but increasingly now we see this growth area in three primary areas, things like mobile communications, like 5G, millimeter wave beamforming, MIMO kinds of things, radar, like automotive radar, and military and aerospace and defense radar systems. And then all these LEO satellites, these communication systems that are being launched. These LEO satellites have a very short orbital period, and so they're constantly zooming across the sky, and so the non-mechanical nature of steering a phased array antenna allows you to lock into one of the satellites, track it as it moves.